Earth Science by Sammy Bernstein. Jules Verne was an author from the 1800s that wrote science fiction books that could have happened but hadn't happened yet. He wrote the book The Journey to the Center of the Earth by using the limited scientific knowledge that he had and that other people knew when he was alive and his imagination. He thought it was possible to get to the center of the Earth by going through strange chambers and that there were Dimetrodon dinosaurs underground. But now we know that much of what he wrote in his book is physically impossible. He also thought that as you get deeper, it gets colder, but that is not true. But as you can see in this diagram, temperature change is extreme, but unlike what Jules Verne thought, we know today that it gets much hotter as you go deeper into the Earth. The crust has a temperature of about 0 degrees Celsius, but obviously it is not always freezing outside, so that is just their estimation. The upper mantle and the asthenosphere have a temperature of about 870 degrees Celsius. Here the rock is soft and is not solid anymore, but isn't completely liquid. The soft mantle is as hot as 3,700 degrees Celsius, so it can flow. The outer core is about 4,300 degrees Celsius, but the inner core is as hot as the sun. It is about 7,200 degrees Celsius. The outer core told us a lot about the inside of the Earth. Here's how. There are two types of seismic waves that exist on our planet. One are P waves, and the other are S waves. These two waves are actually quite different. P waves go forward and backwards. A slinky is a good example of what a P wave looks like. These are faster and can pass through liquids. S waves are pretty much the opposite. They go in side-to-side motions and can be shown by wiggling a rope side to side. These can't pass through liquids, so when they hit a liquid substance, they will stop. Earthquakes and human-made blasts create seismic waves, so pretty much all the time we can make new diagrams of the inside of the Earth using seismic tomography. What scientists have noticed is that S waves don't pass through the center of the Earth for some reason. They realize that the outer core must be liquid. Different materials set at different layers for a reason. This is why. The core is made of iron, and out of the materials that the layers of the Earth are made of, iron is the most dense. As I said before, the outer core is liquid, but the inner core isn't. Why isn't it liquid? Well, this is because, although the temperature at the core of the Earth is as hot as the sun, the inner core has too much pressure on it, so it stays in solid iron form. Water floats on the surface above the crust because it is less dense than aluminum, silicon, and iron. The mantle is made up of a lot of different rocks and minerals. The lower mantle may be the most important layer of the Earth. As the lower mantle rubs on the outer core, it creates Earth's magnetic field. The magnetic field may not seem very significant to you, but it keeps us safe from extremely dangerous solar radiations. It acts as a lot like a Patronus charm from Harry Potter that keeps Dementors away. Sources come from pictures from the Journey to the Center of the Earth movie, pictures from science textbook, class discussions, assorted images from the internet, Journey to the Center lab handout, and class Dropbox image gallery.